I don't usually do videos for the practice problems, but I think that in light of the newness of this material, I thought I would make one for you in this case. So the force of gravity on Mars is less than half of that on Earth. A ball thrown upwards can be modeled using h equals minus 2t squared plus 4t plus 6, where h is height in feet and t is time in seconds. So if we just look at this standard form of the equation, we know that height is going on the y-axis, time is going on the x-axis, and this is telling me that when I throw the ball, or when t equals 0, I am throwing it from 6 feet off the ground. And that, of course, is coming from the c value in standard form, or when t is 0, h is 6. Now, the question says, what is the maximum height of the ball? Well, of course, in order to do that, I need to get the zeros so that I can get the axis of symmetry. From the axis of symmetry, I will get the y value of the vertex, which will give me the maximum height of the ball. So the first thing I'm going to do is factor that -2 out from all of the terms in standard form. So -2t squared divided by -2 gives me t squared, plus 4t divided by -2 is minus 2t, and plus 6 divided by -2 is minus 3. Now I'm looking for the two numbers that multiply to -3 and add to -2, and that will be minus 3 and plus 1. Because -3 times positive 1 is -3, and -3 plus 1 is minus 2. This tells me that my zeros are minus 1 and positive 3. So we know that axis of symmetry is x equals 1. I will pop that in. Sorry, not x. This is t. T equals 1. And so I'm going to pop that into my equation and solve for h at when t is 1. And we know that -2 times -2 times 2 is 8. So that tells me that the height on the axis of symmetry is 8. I have enough information to complete my sketch, and I also know that 8 is the maximum height of the ball. Sorry, that's not a great curve, but we can make our therefore statement that 8 is the maximum height of the ball. When does the ball reach its maximum height? Well, we know that our axis of symmetry, time equals 1, which means that is when our ball reaches its maximum height. So the ball reaches its maximum height at 1 second. And when does the ball hit the ground? Well, remember, that was the other 0, because we can look at our sketch and know that we're height is 0 when I'm on the ground. And so that says that the ball hits the ground at 3 seconds. Now, notice that time in this case, in Mathland, can be negative. Well, of course, time can never be negative. But this part of the graph over here, of course, that happens before we throw the ball. And so the ball is thrown from 6 feet in the air. And so all of this negative time back here, it doesn't exist. But that is what would the trajectory have been had it been thrown from the ground. The path of a firework is given by h equals minus 5t squared plus 20t, where h is the height in meters and t is the time in seconds. So we've asked, let's find the maximum height of the firework. I'm also curious about where we're setting off the firework. Are we setting it off from the top of a building, or are we setting it off from the ground? So what is h when t is 0? Well, note there is no c value, or the c value is 0 in this equation. which means that we are setting this firework off from the ground. Okay, so our y-intercept is 0, 0. So h is 0 when t is 0. So now we're going to use that because that will be one of our zeros. So let's find the maximum height of the firework. We need to factor this. And so the common factor in this equation here, I'm hoping you can see that, is minus 5t is common to both terms. So we'll factor it out. So this says, of course, this t, so negative 5t equals 0. That only happens when t equals 0. And the other t will be at 4. So over here at 4 seconds. So now we're needing to find the axis of symmetry. Well, the axis of symmetry, 0 plus 4 divided by 2 is 2. So our axis of symmetry is at 2 seconds. So we will use that to determine the y value of our vertex. We'll substitute that into our equation. So this tells us that the y value of our vertex is 20. Our vertex itself is 220, because we know that from our axis of symmetry and our maximum value. And I hope that makes sense, because fireworks go pretty high in the air. So we have enough that we can sketch our curve. And we can make our therefore statement. Therefore, the maximum height of the firework is 20 meters. After how many seconds does the firework reach its maximum height? Well, that's our axis of symmetry, or it takes 2 seconds for that to happen. Now, this is the first time we've seen one of these. It says, what is the height of the model rocket after 3 seconds? Well, it's just like saying, what is the height of the rocket at 2 seconds? So this time we're going to take the 3 seconds, substitute it into the equation, and solve for h at 3 seconds. So by solving for the height at 3 seconds, we find out that the height is 15 meters off the ground after 3 seconds. And if you look here, that should make good sense, because at 15 meters, we're crossing right about here, which is down here at 3 seconds. So we can verify it from our graph, but we're solving it using algebra. Sorry, it transformed from a firework to a rocket. It's a firework.